Hello all, welcome back to our class. What we discussed in the previous class, I think we had discussed about units of measurements of an angle in the very beginning of the class, and then we discussed the definitions of trigonometric ratios and then relations between trigonometric ratios and then trigonometric ratios of complementary angles, as well as we discussed how to derive trigonometric identities also. So briefly we will look into what are trigonometric identities, right? So what is the very first trigonometric identity? That is sine square theta plus cos square theta is equal to 1, provided what would be the domain of that angle theta, because theta can be any angle over there, because sine and cos are defined for any real angle. So that is why theta can be any real number, right? From this sine square theta plus cos square theta is equal to 1, we can figure out sine values as well as cos values, right? Please have a look. From sine square theta plus cos square theta is equal to 1, we can say that sine square theta is equal to, when you transpose plus cos square theta towards right hand side, it is going to be 1 minus cos square theta. Observe here, this is 1 minus cos square theta. Cos square theta is being a square number, where 1 should be a square number, because 1 can be written as 1 square, 1 cube, 1 power 4, 1 power anything is equal to 1. That is why I am writing this 1 as 1 square minus cos square theta. See, 1 square minus cos square theta is in the form of a square minus b square. So a square minus b square is going to be a minus b times a plus b. So this is about sine square theta. So you can write sine square theta as 1 minus cos theta into 1 plus cos theta, and when you want to write the value of sine theta, then when you remove the square, then you should put plus or minus. So plus or minus square root 1 minus cos square theta, correct? So sine theta is equal to plus or minus root over 1 minus cos square theta. This is the value of sine theta in terms of cos. Now similarly, we can get the value of cos theta in terms of sine theta also, right? So I will write similarly, from sine square theta plus cos square theta is equal to 1, I can write cos square theta is equal to 1 minus sine square theta. Like how you wrote 1 as 1 square, here also we can write 1 as 1 square minus sine square theta, then it can be written as 1 minus sine theta into 1 plus sine theta. And later this cos square theta can be written as cos square theta is equal to 1 minus sine theta multiplied by 1 plus sine theta. So cos square theta is equal to 1 minus sine square theta. From cos square theta is equal to 1 minus sine square theta, if you want to find the value of cos theta, you will have to remove the square, and then you should put plus or minus square root 1 minus sine square theta. So these are the relations between sine square theta as well as cos theta, and how to write sine theta in terms of cos theta as well as cos theta in terms of sine theta. So this is about first trigonometric identity. I repeat, according to the first trigonometric identity, sine square theta plus cos square theta equal to 1, where the domain of theta can be any real number, because sine as well as cos both are defined for any real angle, right? So that is why sine square theta plus cos square theta equal to 1, where theta can be any real number, right? Coming to second trigonometric identity. So have you remembered what is second trigonometric identity that we discussed in the earlier class, right? So that second trigonometric identity is secant square theta minus tan square theta is equal to 1. But here you be extra careful, because secant as well as tan are undefined at theta is equal to 90 degrees. If you find out the value of secant 90, it is going to be undefined, as well as tan 90 is also equal to undefined. And as we discussed earlier, like this is undefined not only for theta is equal to 90 degrees, it can be for any odd multiple of 90 degrees, right? So that is why theta cannot be any odd multiple of 90, that is 2n plus 1 into 90 degrees is pi divided by 2 radians, where n is any integer. I just express the angle in terms of radians. Secant square theta minus tan square theta equal to 1. If you once observe, the term secant square theta minus tan square theta is in the form of a square minus b square. So, what is the formula for a square minus b square? A minus b times a plus b means secant theta minus tan theta into secant theta plus tan theta is equal to 1 is there? Yes, is equal to 1. Here you can understand one thing, that secant theta minus tan theta is one term and secant theta plus tan theta is the other term. When you multiply two different terms and you are getting 1, what does it mean? What do you call both the terms together? For example, x and y, if the product of x and y is equal to 1, if the product of two numbers is equal to 1, then both the numbers x and y are said to be reciprocals to each other or multiplicative inverses to each other. X is the multiplicative inverse of y as well as y is the multiplicative inverse of x. In this case, you can write the value of x as 1 divided by y, because when y is multiplying here, when you transpose it towards the right hand side, it will divide. So, similarly, the value of y is going to be 1 divided by x. You are pretty much clear with this. So, similarly, we are going to find out the value of secant theta minus tan theta in terms of secant theta plus tan theta, vice versa, right. See here, secant theta minus tan theta multiplied by secant theta plus tan theta is equal to 1. What does it mean? As like x into y is equal to 1? Yes, secant theta minus tan theta is the multiplicative inverse of secant theta plus tan theta, as well as secant theta plus tan theta is the multiplicative inverse of secant theta minus tan theta. Okay, let us try to figure out the values of secant theta plus tan theta in terms of secant theta minus tan theta and secant theta minus tan theta in terms of plus tan theta, right. So, from this I am going to find out the value of secant theta minus tan theta. So, secant theta minus tan theta is going to be, when you transpose secant theta plus tan theta towards right hand side, then it is going to be 1 divided by secant theta plus tan theta. So, this is the value of secant theta minus tan theta in terms of secant theta plus tan theta. Similarly, what is the value of secant theta plus tan theta? Secant theta plus tan theta is equal to, now you transpose secant theta minus tan theta towards right hand side, then it is going to be 1 divided by secant theta minus tan theta. So, we can use these two identities in order to solve some typical problems, right. Okay. Going back to the identity, secant square theta minus tan square theta is equal to 1. From that, secant square theta minus tan square theta is equal to 1. Let us try to find the value of secant theta in terms of tan theta as well as tan theta in terms of secant theta. First of all, I am going to figure out the value of secant square theta. So, secant square theta is equal to, transposing minus tan square theta towards right hand side, then it is going to be 1 plus tan square theta. So, this is the value of secant square theta. Since secant square theta is equal to 1 plus tan square theta, therefore, what is the value of secant theta? So, when you remove square, then you put plus or minus square root 1 plus tan square theta. This is the value of secant theta in terms of tan theta. Now, I want the value of tan theta in terms of secant theta. How is that possible? See here, I want tan theta. So, to get the value of tan theta, transpose tan square theta towards right hand side. Then it will be plus tan square theta. But 1 still there, that is why transpose that 1 towards left hand side. Then it would be minus 1. So, therefore, you can find out the value of tan square theta, which is equal to, transposing plus 1 this side, then it is secant square theta minus 1, but not equal to 1 minus secant square theta. So, tan square theta is equal to secant square theta minus 1. Therefore, the value of tan theta is going to be plus or minus square root secant square theta minus 1. So, this way we can figure out the values of tan in terms of secant as well as secant values in terms of tan. This is about second trigonometric identity. So going back to third trigonometric identity. Have you remembered what is third trigonometric identity? See, we already used sine and cos for first trigonometric identity. We used secant and tan for second trigonometric identity. Yes, we are left with two more trigonometric ratios. They are cosecant as well as cot. Of course, we derived them. I am just asking you to remember whether you had it or not. Okay. So, the third trigonometric identity is going to be cosecant square theta minus cot square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. So, what is this cosecant square theta minus cot square theta, and moreover, what is the domain of this trigonometric identity? Like for the first identity, sin square theta plus cos square theta equal to 1, theta can be any real number. So, any real number in the sense real number system is the domain of the first trigonometric identity. Coming back to the second trigonometric identity, secant square theta minus tan square theta is equal to 1, where theta cannot be an odd multiple of 90 degrees. So, that would be the domain of second trigonometric identity. Coming to this cosecant square theta minus cot square theta is equal to 1. Cosecant and cot are defined at every single value except at theta is equal to 0 degrees. Because the value of cosecant 0 is undefined as well as cot 0 is also equal to undefined. As we are in 10th standard, our angles are from 0 degrees to 90 degrees. That is why we know about only 0 degrees. But when you go to plus 1, plus 2 or intermediate, you will get to know about the trigonometric function like the second identity. Except for 0 degrees, it is undefined. Otherwise, for any other values also it is undefined. Yes, cosecant and cot both are undefined, not only for 0 degrees. For every single multiple of 180 degrees. So, that is why we will have to remove them from the domain. Theta cannot be equal to multiples of pi. What is that pi? Pi radians is equal to 180 degrees. So, any multiple of pi where n is any integer. It could be either positive integer or negative integer, right. So, back to this cosecant square theta minus cot square theta equal to 1. It is in the form of a square minus b square. So, again a square minus b square can be written as a plus b into a minus b. So, cosecant square theta minus cot square theta is equal to 1 can be written as a square minus b square, means cosecant theta minus cot theta into means a minus b into a plus b, that is cosecant theta plus cot theta is equal to 1. Again we can understand one thing here. What is that? Product of two terms is equal to 1. Then what do you call both the two terms? Yes, they are said to be multiplicative inverses to one another. So, cosecant theta minus cot theta is the multiplicative inverse of cosecant theta plus cot theta, as well as cosecant theta plus cot theta is the multiplicative inverse of cosecant theta minus cot theta. So, let us try to figure out the values of both. That implies cosecant theta minus cot theta is going to be transpose cosecant theta plus cot theta that side, then it would be 1 divided by cosecant theta plus cot theta. And similarly, what is the value of cosecant theta plus cot theta? Yes, it is going to be 1 divided by cosecant theta minus cot theta. So, this is about the reciprocals. And now, back to our equation, that is identity. Cosecant square theta minus cot square theta is equal to 1. From this, let us try to find out the values of cosecant as well as cot. Okay. From this, cosecant square theta is equal to transpose minus cot square theta that side. It would be 1 plus cot square theta, and then cosecant theta is equal to plus or minus square root 1 plus cot square theta, right. So, cosecant theta value in terms of cot. Similarly, how to find the value of cot square theta in terms of cosecant? Yes, see here it is 1 plus cot square theta, right. Transpose 1 this side, then left with cot square theta. So, cot square theta is equal to, when you transpose 1 towards left hand side, then it is going to be cosecant square theta minus 1. right. So, this is cot square theta is equal to cosecant square theta minus 1. Therefore, the value of cot theta is going to be plus or minus root over cosecant square theta minus 1. Hope you understand about all these three trigonometric identities, and we elaborated every single trigonometric ratio in terms of the other ratio. Got my point? Right. So, these three are three trigonometric identities. So, let us try to understand all these six like three trigonometric identities by using some examples. Okay, right. Suppose you are given one problem, that is evaluate sin square x plus cos to the power of 4x divided by sin to the power of 4x plus cos square x, and more precisely evaluate sin square x plus cos to the power of 4x divided by sin to the power of 4x plus cos square x. How do you simplify this? Evaluate in the sense, try to reduce it into simplest terms. How do you reduce this given function into its simplest terms? Like sin square x plus cos to the power of 4x by sin to the power of 4x plus cos square x. The given problem or the given function is in terms of sin as well as cos. So, it is understood one thing, that convert everything in terms of either sin or everything in terms of either cos. There ends the matter, right. So, I am trying to fix this entire problem in terms of sin. Means, if there is any sin term, I leave it like that. If there is any other than sin term, I am going to convert it into sin, right. So, first sin square x is sin square x because it is already in terms of sin, and cos power 4x. I know cos square x in terms of sin. Just now we discussed about identities. The value of sin square x is equal to 1 minus cos square x as well as cos square x is equal to 1 minus sin square x. So, that I am writing cos to the power of 4x as cos square x whole square, right, whole divided by sin to the power of 4x is already in terms of sin. So, sin to the power of 4x plus cos square x. Yes, I know what is the value of cos square x in terms of sin. That is cos square x is equal to 1 minus sin square x. See, the denominator is completely converted in terms of sin. Now, my task is to convert the numerator in terms of sin. For that, sin square x is sin square x plus cos square x. Instead of cos square x, I can write 1 minus sin square x. Square is there, so whole square, whole divided by, there is no change in the denominator. I would write sin to the power of 4x plus 1 minus sin square x. In order to simplify the numerator is sin square x plus, see, 1 minus sin square x whole square is in the form of a minus b whole square. And if you expand 1 minus sin square x whole square by using the identity a minus b whole square, then it is going to be a square, means 1 square, plus b square, that is sin square x whole square, minus 2ab minus 2 into a is equal to 1 and b is equal to sin square x, whole divided by, same denominator there is no change, that is sin to the power of 4x plus 1 minus sin square x, right. Now, simplify this. This is sin square x, means 1 sin square x minus 2 into 1 is equal to 2 sin square x. 1 sin square x minus 2 sin square x is equal to how much? Minus 1 sin square x, means minus sin square x. And then plus 1 square is going to be 1 plus sin square x whole square, it is in the form of a to the power of m whole to the power of n, which is equal to a to the power of m times n, means 2 times 2 equal to 4. Then it would be sin to the power of 4x whole divided by, this is sin to the power of 4x plus 1 minus sin square x. Once you observe both numerator and denominator, minus sin square x is there in the numerator, minus sin square x is there in the denominator. Plus 1 is there in the numerator, plus 1 is there, and plus sine to the power of 4x, sine to the power of 4x. What does it mean? Both numerator and denominator are same, gets cancelled, then which is equal to 1. Therefore, the value of sine square x plus cos to the power of 4x divided by sine to the power of 4x plus cos square x is going to be 1. So, with this we can actually estimate and create some problems like, for example, I did not give you evaluate, okay. I gave you the function like if f of x is equal to, right, the function given as if f of x is equal to sine square x plus cos power 4x by cos square x plus sine to the power of 4x, then find the value of f of 2020. So, in order to find the value of f of 2020, you do not have to substitute 2020 in the place of x and you will have to solve, right. First, if you evaluate, you get the value of this function is going to be 1. Since the value of this function is equal to 1, you can understand that therefore, f of x is equal to 1. F of x is equal to 1 means what? It is being a constant function. What do you mean by constant function? Whatever the value of x you put, the output is always 1, right. If you put x is equal to x or x equal to 1 or x equal to 0 or x equal to any number, so that you are going to figure out the value of f of 2020. F of 2020 will also be equal to 1. So, this way you can answer problems of this kind. Hope you understand, right. So, we will move on to one more example, that is example 2, that is going to be if tan theta plus cot theta is equal to 2, if tan theta plus cot theta is equal to 2, find the value of tan square theta plus cot square theta. What is the information given in the problem and what are you going to find? The value of tan theta plus cot theta is given as 2. Now, you are going to find the value of tan square theta plus cot square theta. How is that possible? See, when you observe the information given in the problem, that is tan theta plus cot theta is given as 2. Since you need to find the value of tan square theta plus cot square theta, it is understood that you need to square it on both the sides. When you square it on both the sides, then only you get tan square as well as cot square. So, that we should square it on both the sides. By squaring on both the sides, we get tan theta plus cot theta whole square is equal to 2 whole square, right. Now, tan theta plus cot theta whole square is in the form of a plus b whole square. What is the expansion for a plus b whole square? A square, that is tan square theta, plus b square, that is cot square theta, plus 2ab, that is 2 into tan theta into cot theta, which is equal to 2 whole square is equal to how much? Which is equal to 4. So, tan square theta is tan square theta plus cot square theta is cot square theta plus 2 into, what is the value of tan theta into cot theta? If you once observe and just go back to your relations between trigonometric ratios, tan theta is equal to 1 by cot theta and cot theta is equal to 1 by tan theta. So, tan theta into cot theta is equal to 1 because both are reciprocals to each other. Therefore, the value of tan theta into cot theta is going to be 1, which is equal to 4, right. From this, tan square theta plus cot square theta is equal to, see, this is 2 into 1 equal to 2. When you transpose plus 2 towards right hand side, then it is going to be 4 minus 2, which is equal to 2. Therefore, the value of tan square theta plus cot square theta is going to be 2. That's in that way we can find out the value of tan square theta plus cot square theta when you are given tan theta plus cot theta is equal to 2, right. And next, moving on to the next example, that is, suppose when you are given one trigonometric ratio and how to express all the other trigonometric ratios in terms of that single trigonometric ratio. Hope you understand my question. I am going to write it on the board, that is express all trigonometric ratios, all t ratios are nothing but all trigonometric ratios in terms of all trigonometric ratios in terms of secant theta. How to express every single trigonometric ratio in terms of secant theta? What does it mean? Sin theta is equal to how much? It should be in terms of secant. Cos theta is equal to how much? Again it should be in terms of only secant, not in the other trigonometric ratios. So, how do I express every single trigonometric ratio in terms of secant theta? For that, I am going to consider secant theta is equal to some x, right? Secant theta is equal to x. What is the definition of secant theta? We already defined sine, cos, tan, cosecant, secant according to an acute angle theta from a right angle triangle. You remembered? Right. So, from that secant theta is equal to x. The definition of secant theta is going to be, yes, what is the definition of secant theta? Hypotenuse divided by side adjacent to theta, right? This is the definition of secant theta. But this is x only, so that I am going to write it as x divided by 1. For this, I am going to form a right angled triangle here. In this right angled triangle, this is right angle, as well as one of the angles should be theta. So, this is the angle theta, right? Secant theta is equal to x by 1, which is equal to hypotenuse by side adjacent to theta. Now, I am going to figure out what is the hypotenuse is equal to x, but I should not write x. It should be hypotenuse is equal to some constant into x, as well as side adjacent to theta is equal to 1. 1 into the constant is the constant. With the help of these two, I am going to find out the side opposite to theta. How can I figure out the value of the side opposite to theta? Yes, since it is a right angle triangle, by using Pythagoras theorem. So, let it be some A, B, C, right? I am going to find out the value of AB by using Pythagoras theorem. What it is? Hypotenuse square equal to side square plus side square. So, hypotenuse square is nothing but kx whole square is equal to side square plus side square, that is AB square plus k whole square. Kx whole square is equal to k square x square transpose k square this side minus k square is equal to AB square, right? See, kx square minus k square, when you take one k square common, remaining x square minus 1 is equal to AB square. Therefore, the value of AB is going to be root over k square is equal to k into root over x square minus 1. So, this is the value of AB, right? So, AB is going to be k into root over x square minus 1, right? Now, I know all the three sides of the right angle triangle. I can easily find out every single trigonometric ratio in terms of secant, right? First one, what is the first one? Sin theta, right? So, what is the definition of sin theta? Side opposite to theta by hypotenuse. What is side opposite to theta? K into root over x square minus 1 divided by kx. K and k gets cancelled. Root over x square minus 1, but x is equal to what? Secant theta, right? So, I will write it as root over secant square theta minus 1 divided by x is again secant theta, right? This is the value of sin theta in terms of secant theta. Coming to the second one, what is the second one? Cos theta. I think it is not required to look into the triangle because we have a relation between secant and cos. They are cos theta equal to 1 by secant theta. So, directly we can write it as 1 by the value of secant theta is equal to x. So, 1 by secant theta, right? And then tan theta. Tan theta is equal to, of course, again you do not have to go to the table like that triangle because tan theta is equal to sin theta by cos theta. The value of sin theta is this and the cos theta is this. So, square root secant square theta minus 1 by secant theta whole divided by 1 by secant theta gets cancelled. Then you get root over secant square theta minus 1. This is the value of tan theta. and other 3 trigonometric ratios are the reciprocals of first 3 ratios. Like, what is the fourth one? Fourth one is cosecant theta. Cosecant theta is equal to 1 by sin theta. So, sin theta is this. So, cosecant theta will be reverse of this sine, reciprocal of the sine. So, when you write the reciprocal of sine, then you get secant theta divided by root over secant square theta minus 1. And last trigonometric identity, what is that? Cot theta, because secant is equal to secant. And moreover, cot theta is the reciprocal of tan theta. Here you get tan theta is equal to root secant square theta minus 1, and the reciprocal of this is 1 divided by root over secant square theta minus 1. So, like this we can express every single trigonometric ratio in terms of secant. Not only for secant, in terms of sine, cos, tan, cosecant, secant. This is only the standardized procedure to express them in the same trigonometric ratio. Hope you understand. So, this is about trigonometric identities, and we had discussed some examples on that. Hope you understand. Thank you.